Good day, everyone. Today we're going to discuss chemistry for senior high school, chapter 1, Matter and Energy. Our agendas for today is to discuss lesson 1 to 4. Lesson 1.1, Matter and its classification. Lesson 1.2, Physical and chemical changes and properties of matter. Lesson 1.3, Energy and energy changes. And lastly, Lesson 1.4, Scientific inquiry. Learning objectives. At the end of this lesson, the student is able to identify matter and its classification, master the concepts of 3 states of matter, to have thorough understanding of physical and chemical properties of matter, explain briefly about energy and energy changes, lastly, give examples of different types of energy. Lesson 1.1, Matter and its classification. Hello everyone, I'm Anna, and today we'll be discussing Lesson 1.1, Matter and its classification. All the things that I've observed in our home are examples of matter. The TV, radio, the hot coffee, and the burger I had for lunch, even myself, are examples of matter. What is matter? Matter is everywhere. We can see it inside our home, backyard, school, the food we eat, and many more. It occupies space and has mass. Examples of object that has matter are table, laptop, chair, water, and air. Earlier, it was mentioned that matter has mass. Now, we will define what is mass. Mass is the measure of matter present in a particular object. Its interaction with gravity creates weight, which can be measured by a scale or balance. Examples of objects that has mass. We have trophy, light bulb, piano, and many more. There are different units in calculating mass, like kilograms, grams, pounds, and etc. After knowing the brief definition of matter and mass, I remembered that some of my observations were not of matter. Sunlight and heat of motorcycle engines are matter. Moving on to the next topic, we'll be talking about the composition of matter. One way to classify matter is by its chemical composition. Such matter is known as pure substance. A pure substance has a fixed composition throughout and from sample to sample. It cannot be separated in two components by any physical means. Example, the aluminum in Anna's fruit drink can is pure. It is not combined with other substances, although it is coated with plastic and paint. On the other hand, mixtures are also known to have two or more pure substances and may vary in composition. The fountain, for example, is made from a mixture of gravel, concrete, and pebbles. Even the water in a fountain is not a pure substance, since small amounts of gases and minerals are dissolved in it. Do you know the two types of pure substance? The two types of pure substance are elements and compound. Elements are substances that cannot be broken into simpler substances, even if there is a chemical reaction. It is also the building blocks of all matter. Elements are classified into two main categories, which are metal and non-metal. Iron, copper, aluminum, and other metals are good conductors of electricity. Non-metals like carbon, chlorine, and sulfur normally are not. Compound is composed of two or more elements that is combined in definite proportion. It is also known as chemical compound. Compound has properties that is different from those of its component elements. Iron pyrite can be broken into two component elements, iron and sulfur, but its characteristics are different from both. A chemical formula describes the composition of the compound by using the symbols of elements that makes up the compound. The subscript number shows the relative proportions of the element in the compound. A mixture is composed of two or more elements or compounds. It has a possibility to separate mixtures into their component pure substance. Mixtures may differ in uniformity and composition. Homogeneous mixture has a uniform composition throughout and it is known as solution. A mixture that is not uniform throughout, a sample mixture of salt and pepper for instance, is heterogeneous mixture. Lesson 1.2: Physical and Chemical Changes and Properties of Matter. Hello everyone, I'm Jane and we'll start to discuss Lesson 1.2. Do you remember the three states of matter? Solid, liquid, and gas. Now we will define solid, liquid, and gas. A solid has a fixed shape that is not related to the shape of the container holding it. To make this clear, take an iron pipe in a box, for example. The pipe does not change shape. A solid cannot be compressed because its particles are arranged in a tightly packed, highly ordered structure that does not include much free space into which they might be squeezed. However, there are some solids that are capable of changing shape if enough force is applied. A liquid has no fixed shape. The particles are not firmly arranged and have little space for them to move past each other, thus it can be slightly compressed. A gas has no fixed shape, just like the liquid. The difference are its particles, as they are widely separated with much empty space between them. It expands to fill available space completely. When gases cool sufficiently, they become liquids or even solids. An example is when water vapor in the air liquefies on the surface of a cold glass. To show the solid, gas, and liquid state of a substance when representing it symbolically, simply add an enclosed parenthesis with an S, G, and I in it respectively. The symbol AQ represents aqueous solution, a solution in which a substance is dissolved in water. Examples of this are H2O solid form, H2O gas form, H2O liquid form, NaCl sodium chloride, in aqueous solution form. Physical and chemical changes and properties of matter. A physical property is a characteristic that we can observe or measure without changing the composition of the substance. Examples of this are odor, taste, hardness, mass, volume, density, magnetism, conductivity, and the temperatures at which a substance changes from one physical state to another. Mass, as you all remember, is the measure of the quantity of matter. These are reported in varying units like grams, kilograms, and milligrams, depending on the substance or desired unit. Converting a unit to another should follow the metric value reference. Volume is the amount of space a substance occupies. We can determine the volume of a rectangular solid such as a cube by measuring its length, width, height, and then multiplying them. Density of an object is a ratio of its mass to its volume. The density, unlike the volume and mass, does not depend on the size of the object or sample. Density is an unvarying property of a substance no matter how much of it is present, as long as the temperature and measure are constant. To make things clear, let's look at an example. The density of water at 4 degrees Celsius is 1 grams per milliliter. It doesn't matter if we have 10 milliliter or 10 liters. The ratio of mass to volume would be the same, 1 grams per milliliter. However, if the temperature increases, the water would expand to a larger volume while the mass stays the same. The density of water would decrease as the temperature increases. Here is the equation for density and its relation to mass and volume. Density equals mass over volume. Temperature is a measure of how hot or cold something is relative to some standard. Standard scales are Fahrenheit, which is rarely used in science, Kelvin, and Celsius. The boiling point is the temperature at which the liquid form of a substance changes to gaseous form. It is independent of sample size. The melting point when the substance changes from a solid to liquid. Here are the formulas to convert to different temperature scales: Celsius to Kelvin, Fahrenheit to Celsius, and vice versa. Physical changes. It is the process that changes the physical properties of a substance without changing its chemical composition. An example we can consider is when we can change liquid to water vapor by heating it. The transition is called boiling or vaporization. It is a physical change since both forms involve the same chemical substance, water, which is H2O. Chemical changes is the process in which one or more substances are converted into one or more new substances. Like when pen is tarnished, some of the copper and zinc metal atoms in them combine with oxygen, forming compounds called metal oxides. The compounds are chemically different from either of the elements that form them. A chemical property is defined by what it is composed of, what chemical changes it can undergo. Let's compare hydrogen and helium. Although they have similar physical properties, both are colorless gases with similar densities. Their chemical properties are very different. While hydrogen reacts with many other elements that compounds, helium is considered inert. It has not yet been shown to react with any other element or compound. Lesson 1.3: Energy and Energy Changes. Hello everyone, welcome to Lesson 1.3. Are you excited to learn more about energy? What is energy? Energy is the essential requirement to make physical things move or move the way it wants to. It does not stop at physical things, attitude, behavior, and properties of physical anything. It can be everywhere. Our universe is mostly forming of energy. When we see galaxies and stars, they are combined with aspects of various kinds of energy compressed in one's dimension or specific place in space. Without these things, our universe will be a complete dark and black place. What are energy changes? Energy changes is the kind of change that happens in breaking and bonding. When a chemical reaction occurs, the following happens. The reactants bond are shattered and in the products, new bonds are produced. To break bonds, energy is taken in. Also, endothermic processes are used to break bonds. As new bonds form, energy is released. The process of bonding is exothermic. The energy required to break bonds versus the energy released when new bonds are formed determines whether a reaction is endothermic or exothermic. Now we're going to tackle the kinds of energy. We have heat, kinetic, potential, mechanical, light, electrical, magnetic, chemical, and nuclear energy. First, we have heat energy, is the path of energy that consists of warm energy going to the cooler object. Heat is not just defined as hot. Cold is also part of the heat. Heat energy can be said to be anywhere. It is in icebergs, glaciers, volcanoes, and especially our bodies. This will make sense if you think about particles and atoms moving at certain place or everywhere in the world. The moving particles are the result or outcome of heat energy because heat energy flows through temperature differences between two objects. In general, this is true meaning of heat. Second, kinetic energy is the transfer of energy using physical ways, such as force and work. An example of this is yo-yo. The yo-yo is an outstanding demonstration of how kinetic energy is transformed. When you first start playing with it, you should let it rest in your hand. At this time, the ball has all its energy stored in the form of potential energy. When yo-yo is dropped, the stored energy is converted into kinetic energy or movement energy. All the energy is transferred to kinetic energy once the ball hits the yo-yo bottom. Third is potential energy, is a different transferred way of energy to an object. It can only be potential energy when the energy itself decides to stay inside the object. In general, some energy is left inside. To make this understandable, there are types of potential energy that are rarely known to people. It is gravitational potential energy. It is the potential energy in which the object is possessed by the position relating to each other. Example is the moon and earth. They have gravitational potential energy. Fourth is mechanical energy. It is an energy that is formed through motion. It is also a matter of physical science. When an object is moving from kinetic energy, mechanical energy also takes place. However, if you ask me what is the difference between kinetic energy and mechanical energy, the difference between them is kinetic energy is made from types of energy, while mechanical energy is from through motion. Fifth is light energy. It is the natural energy that is produced from the vibrations of particles itself. An example of light energy is cooking or making the food hot in a microwave oven. Six is electrical energy. It is the movement of electrons from one atom to another atom, which cause particles to be charged and form to what we sometimes see as electric. In addition, electrical energy is formed within electrical fields, so I will explain it. The areas surrounding a charged particle are known as electrical fields. Charged particles, in other words, form electrical fields that exert force on other charged particles in the field. The electrical field exerts a force on the charged particle, forcing it to move and in turn perform work. Seventh, magnetic energy is formed from the magnetic field. Magnetic fields are formed from magnets. Also, any materials that generate a magnetic field is referred to as a magnet. The north pole and south pole of a magnet are opposite one another. The magnetic field is stronger at each end. These are opposites to be sure. Only opposite poles can be used to join magnets. You join two north poles or two south poles, for example, but the magnets will reject each other if you try to connect two north poles or two south poles. Eighth is chemical energy, is the energy held in the bonds of chemical compounds such as atoms and molecules, and when a chemical reaction takes place, this energy is released. When a substance chemical energy is released, it evolves into completely new material. An example of this is solar energy. So in the process of solar energy, ingredients like water, carbon dioxide, and sugar stick together as one by the chemical bonds that holds each of them. Solar energy is required by plants. Last example is nuclear energy, is the energy that is made from atoms that splits apart. If all power plants make or convert electricity through steam, then in nuclear power plants, the heat to make the steam comes from the atoms being split half or apart. In general, this process is called fission. Lesson 1.4 Scientific Inquiry. Inquiry is a process of asking questions or conducting research in order to gain a better understanding of a subject. Scientific inquiry, which includes observation, testing hypotheses, gather all relevant data and construct a hypothesis based on the facts, and determining the findings of the experiment.